Hello, good afternoon, everyone. Welcome to UGC NET exam preparation. As you all know, this is the lecture series for paper 2 Environmental Science. And here's the third class. In this class, we are going to study about lithosphere. And apart from lithosphere, we are going to talk about laws of thermodynamics also. So let's start this class. So this is the syllabus, as I have mentioned in the earlier class that I'll try to mention this syllabus in every slide so that you will be familiar with the topics which is covered under syllabus. So let's begin with the definition of lithosphere. Lithosphere is the outermost layer of the earth. They are consisting of crust and outermost part of the mantle. Crust is nothing but the outer portion of our earth. This is crust. Crust also two types. One is this is land. Land is crust. This is land. This land crust is called continental crust. The ocean part is called, the water part is called oceanic crust. So these two, oceanic crust and continental crust, they put together called as a crust. Then our uppermost part of the mantle. After earth crust, the second layer is mantle. The mantle layer. Mantle also divided into two, upper layer and upper mantle and lower mantle. In the uppermost portion of the mantle, there also comes under lithosphere. Lithosphere are two combination of crust and uppermost portion which is solid material. This lithosphere is this. This is crust. Wait, I'll remove some of this mark. Yeah. So this is crust. So this is earth crust, and this is uppermost portion of mantle. These two, these two, they together form the lithosphere. Okay, and they are rigid and divided into tectonics. This lithosphere, they are divided into multiple plates. That plates are called tectonic plates. They are in a multiple plates here. Multiple plates are there, and they are floating over asthenospheres. This is another uh, layer. They are in semi-fluid form. They are in semi-liquid. So above this astronosphere, there are multiple plates, the lithosphere there floating. So this is the definition of lithosphere. Lithosphere is nothing but their uppermost layer of the earth. They consist of two. One is the crust and the another one is uppermost portion of the mantle. They are floating over semi-fluid astronosphere. Okay, please remember that. Then comes to the composition of the lithosphere. The lithosphere composed of crust and upper mantle. As mentioned in the previous slide also, the crust is the outer layer of our Earth. They are also subdivided into two, continental crust and oceanic crust. The continental crust, they are very rich. In the continental crust, the highest rich mineral available, they are granite. Granite also one of the minerals. Silica also minerals. Aluminium. These minerals are very rich in continental crust. They are also often called as a Cl. In Cl, S I means silica, and Al means aluminium. This is a symbol for these two uh, minerals, and comes to oceanic crust. They are composed mostly of basalt. This basalt is a rock. These rocks are rich in silica and magnesium, and they are also often called silica and magnesium. Please remember, oceanic crust. Under oceanic crust, the rich minerals, they are silica and magnesium, and in short, they are called as SEMA in continental crust rich minerals. They are granite, silica, aluminum. They are also called as Cl. Then second, upper mantle, upper portion of the mantle. They are mainly composed of silicate minerals. They are called olivine and pyroxene. Olivine and pyroxene. These two minerals are composed or, or found in upper portion of the mantle. So please remember what kind of minerals are found in upper part of mantle layer. They are olivine and pyroxene. Okay, so this is about the lithosphere. These two are about lithosphere. Then comes to our second topic, that is laws of thermodynamics. So what is the laws of thermodynamics? What is that? The laws of thermodynamics are fundamental principles that describe, that tell us how the energy, how this energy flows and transport in a system, how energy is flowing, how they are transforming in a system. So this law tell us how the energy flows and transform in a system under laws of thermodynamics. These laws apply to all kind of physical and biological process, including environmental chemistry, environmental science, in many other. Wherever there is energy, these laws are applied. The first law. So let's see the first law. First law is law of conservation of energy. What does it mean? It means energy, the energy that cannot be created. No one can create the energy, or no one can destroy. The energy neither can create nor destroy, only transform from one form to another form. The energy can be only transformed from one form to another form. For example, plants convert sunlight, solar, that is solar energy, into chemical energy through the process of photosynthesis. The sunlight are converted to chemical energy through the process of photosynthesis. Then another example, a car engine converts its chemical energy, that is fuel. Fuels are chemical energy. They convert into mechanical energy. There, because of fuel, they are moving, they are running the cars. So this is second. So first law says that energy cannot be created or destroyed. That can be only transformed from one to another form. Okay, this is first law. Please remember, first law is law of conservation of energy. Then comes to second law. Second law is law of entropy or energy degradation. What it means, in any energy transfer or transformation, some of that energy is lost as a heat, increasing the entropy disorder of the system. So when one energy, just for example, this is one kind of energy. Here it is 100%. Just take it 100%. Okay. When this energy is transferred to another subject, or it is transformed, while transferring, some of this energy are lost as heat. So just take only 90% energy will reach in, or will transform, and remaining 10% will be lost as a heat. So this is second law, the law of entropy, or also called energy degradation. Just example, when the engine runs, some fuel energy is converted into useful work, but large portion is lost as a heat. So this law is called law of entropy. In the food chain also. In the next class, I'll explain food chain, while food in the trophic level of food chain, only 10% energy is passed to next trophic level, and the rest is lost as a heat. So I'll teach you this also in details. So just remember, second law is law of entropy, also called energy degradation. Then comes another topic. This topic also important. heat transfer process. This is heat transfer process. Law of thermodynamics is completed. Here, these two laws are important. Many times questions are asked from here directly or indirectly. So remember this one. Then this is another topic, heat transfer process. Heat transfer is the movement of thermal energy from one object or system to another due to temperature difference. There are three main models of heat transfer. Under heat transfer process, there are three modes or three models of heat transfer. One is conduction, second is convection, and the third one is radiation. So let's see the first one. Convection, heat transfer by fluid movement. Sorry. No, this is not this one. Conduction. Yeah, conduction. First one is conduction. That is heat transfer by direct contact. When any subject is directly contact, then heat transfer will occur. Definition: the transfer of heat through a solid material from one molecule to another without the movement of material itself. What it said, transfer of heat through a solid material. Solid material can be anything. That can be metal, that can be wood, plastic, any solid material. From that solid material to another solid material without the movement of material itself. No need to move anything, only heat transfer. So just example, just take an example. A metal spoon gets hot when placed in a hot cup of tea. Just take, this is hot cup of tea. Okay, this is hot due to burning or due to the hot. Just take it as a hot. When you keep in a spoon here for few minutes, for some time, this spoon also going to be this spoon also going to be hot. So this process is called conduction. Not only spoon, any other metal pro- product, be it knife. When you keep here, it will be hot. So this is called heat conduction. Heat travels through a wall of building. A key factor: materials like metal are the very good conductors. They heat very fast as compared to others. Wood, plastic, they are not that much conductor as a metal. They will not become hot as quick as metal. Okay, so this is the first mode of heat and transfer process, that is conduction. Then comes to second. Second is convection, heat transfer by fluid movement. Defin- the transfer of heat in a liquid or gas due to movement of fluid molecules. It is happen due to movement of fluid molecules. It can be transferred through liquid and gas. Okay. Example: boiling water. Just take a boiling water. Hot water rises due to boiling, and cold water sinks. Cold water always remains sinks, creating a convectional current. Okay, boiling water. Sea breeze. Land heats up due to heat. Sunrise. Due to sun, the land heats up faster than water. You will, if you know it already, land is always faster heat up than sea. Okay, causing air movement. When just take example, this is land and this is sea, and the sun rays are coming equally in both, but here the land will become hot faster than this water. Okay, so this is because of movement of fluid molecules, and because of this let become faster heat, the land, air will be traveling, air movement will cause in this. Okay, then key factors occurs in fluids and liquids. This convection there occur only in liquids and gases. Natural convection also there without external force. They naturally happen. And force convection using fans and pumps. So the third one, that is radiation. Radiation by name itself will come to know that heat transfer by electromagnetic waves. No solid, no liquid, no gas. They are transferred by electromagnetic waves. The transfer of heat energy through empty space. There is no medium required to transfer radiation. They are through electromagnetic waves without needing a medium. Example, sun hitting earth. Is there any kind of medium? No, there's no any medium. There's no any solid. There's no any liquid. There's no any gas. They are heating without any medium through electromagnetic waves. So here keep no contact or medium is required. Dark rough surface absorb more radiation than shiny and white surface. As you know, people often do not wear black t-shirt in a summer or hot season. That is the dark color they absorb more radiation, more heat than shiny or white surface. So that's why people often wear white t-shirt, white shirts, white clothes during hot season. That is the one of the reason because white surface they absorb very less radiation. They absorb very less heat. Here I have made a table of comparison. One is medium required example also. These might ask in your exam also. So that's why I have made this to make it simple. In the conduction, what is the medium? Medium required, yes, medium is required. Medium required in both conduction, convection. In both, medium is required. In the conduction, the medium is solid. In the convection, the medium is liquid and gas. In the radiation, as I mentioned just now, there is no medium required. Sunlight, campfire, the examples. Okay, so this is about the heat transfer process. So this is all about today's class. Today, what we studied, we have studied lithosphere, laws of thermodynamics, and heat transfer. So please rem- remember what I taught you today, and these are very important for your exam. So this is all for today. Also, please subscribe to my channel. Also, share with your friends and fellows. So take care. Bye.